Welcome back. If you're joining for the first time, then I've been porting the Sega Mega Drive version of Sonic the Hedgehog to the Commodore Amiga 1200 computer. And I'm excited to say that for the very first time, the game is partially playable. Sonic has entered Green Hill Zone, and everything so far feels identical to the original. The physics, the movement, and the collision is all spot on. You can even collect a ring or two. There's still a long way to go, but the core components of the game engine are really taking shape. One of the advantages of porting the original code in this manner is that the behaviour of the game feels indistinguishable from the original. It's not my interpretation, it will play identically, and thankfully the logic of Sonic's handling is well abstracted from the rendering, which I've been spending a lot of time on. Porting the logic was quick and easy, and I only spent a couple of days on this aspect. However, April has been the most challenging period of the project so far. I started the month with the realisation that the level scrolling had to be rewritten for the third time. No. Why have I rewritten scrolling so many times over? Well, it's really one of the most toughest challenges of this project. It is easy to scroll on the Amiga, but once you introduce independently scrolling layers, a per scanline scroll, and an extremely large 8-way scrolling play area, it's very easy to run into problems. These can be performance related, memory restrictions, or simply backing yourself into a technical cul-de-sac by trying to do too many hardware tricks at once, which then disable you from being able to do something later. To recap, my first attempt was the most obvious one. I used the Amiga's dual playfield mode. The Amiga hardware supports this out of the box, making it a clear first choice to get started. The downside being it restricted the foreground layer and all the sprites to a shared 16-colour palette. This would have visually compromised the game, but it allowed me to get something up and running that performed well as a proof of concept. Some people have mentioned that Kid Chaos makes great use of this mode on the A500 with a far reduced colour palette, and whilst I think Kid Chaos is technically excellent, it uses some interesting mid-frame colour changing tricks and a clever graphics design. It is a game visually designed for the Amiga hardware. Sonic is not, and many of the techniques that Kid Chaos uses simply wouldn't be applicable for Sonic from a visual perspective. I then adopted a second approach. To boost the number of colours, I dropped dual playfield and assigned an extra bit plane to the foreground layer, increasing the colour palette from 16 to 32. I offloaded the background layer onto the Amiga sprite hardware, retaining 16 colours. The downside to this approach is that tiling sprites for the background requires more copper time, and I was already leaning on the copper quite heavily to perform a vertical Y split of the playfield to handle wrapping. Now, a game without much vertical scrolling can just allocate a playfield as tall as the game world itself. But Sonic's levels are very tall and very wide. We don't have memory for this. Effectively, I ran out of copper time, which meant I was unable to also implement the per scanline changes I wanted on the background layer. This made me sad. So this brings us to this month's rework, and it's the best one yet. It removes the copper Y split entirely. This means we now have time for a per scanline scroll on the background, as we did with the original dual playfield approach. However, we now also have the shared 32 colour palette, and we're using fewer DMA slots, so we could potentially add mid-screen colour change effects in the future. You might be wondering, why only use 5-bit planes? Why not use 6 and double the colour palette to the 64 colours used on the Mega Drive? It's due to the extra data that needs to be moved around with every extra plane added. It would require more memory, and it would immediately mean 20% more transfer time for any graphics objects. Much as I love the flexibility of the Amiga's blitter, it is slow as sin compared with the Mega Drive's sprite hardware. That is a technical fact. The Mega Drive can fill up to 80 32 by 32 sprites a frame with transparency, and no amount of wishful thinking can make the Amiga perform this feat for a flexible use case. Regardless, the end result is that scrolling is now flexible and fast. I actually think I'm finally done with scrolling now. Hopefully I'll never have to make a YouTube video about scrolling ever again. Sorry if you enjoyed them, but let's not count our chicks before they hatch. But I know what you're thinking. How does this run on hardware? And I apologise, like my setup isn't really good to do this, but I have got an original Mega Drive control pad plugged into the Amiga, just directly plugged in. Now, if you look online, some people will tell you not to do this because it could damage your Amiga. But as we know here at Reassembler, we like to live a little dangerously, so I've just gone and done it. Now, the interesting thing is, this actually runs perfectly on WinUAE, Cycle Accurate, etc., as an A1200. But when I run it on hardware, it doesn't quite work correctly. It works up until the point where I can scroll around in debug mode. You can see here the screen's updating, the frame rate's smooth, everything's looking pretty good. But what happens if I actually turn on sprites? And I'll just do this with a debug key. So there I've got the debug ring. Look, it's working. But as soon as I turn this ring into Sonic, which is a slightly more complex sprite to build, the screen flashes a lot. So the game is actually running here. Like, if you see, I can run around as Sonic, but it's obviously not running properly. And you might be wondering, well, why is that? The answer is, I believe, that I'm trying to do too much in the vertical blanking period. And the vertical blanking period is effectively when the scan line gets to the bottom of the active display window. You've got a bit of time before it jumps back up to the top of the screen again. That's often when you do a lot of graphical operations. And really, in this vertical blanking period, my sprite code is too slow. So what's happening is that the sprites are trying to update mid-frame. It's causing lots of flickering. It's causing things that need to happen on a per scanline basis to be delayed, and it's causing problems. But that being said, this is actually the first time I've had the scrolling running on the Amiga. With a project of this nature, what tends to happen is you've got to kind of develop the game and prove out that things are working. So you're coding away on an emulator doing that. Then you try and run it on hardware, because obviously getting the code onto the hardware takes a little bit of extra time, and I've got to rejig my limited setup here. Then you realise, oh, the emulator didn't quite match hardware, and now I've got to go back and do another round of optimizations and changes. So you've always got to be checking on hardware, because as great as WinUAE is, sometimes there are timing differences. It's a lot more lenient in terms of what it lets you do. That being said, look, I mean, it is all running and it's looking good, and I'm pretty confident that with a bit more time, I can get this running well. I was really hoping that this video would be me showing you Sonic playing on the Amiga with an original control pad, but it just wasn't meant to be. And sometimes doing these YouTube videos, you kind of run into this. You've got to think, what's going to make for the best YouTube video, and also what's in the interest of the project. And sometimes those things don't really go hand in hand. Making a good YouTube video can cause you to take a shortcut that you wouldn't really want to take normally, because maybe it's going to cause you problems further down the line. But, you know, I think the point in case is here, I just want to be transparent about where we are with this. Come on, let's make Sonic run round the loop with a flashing screen. Obviously, the frame rate drops when this is happening because I'm doing too much in the V-blank, so it causes Sonic to miss a frame. But you can kind of see, you know, if I play this game blind here, it is actually playing. And so we've just got to do a bit more, in the way of optimization to get there. So that's what you're going to see next. I hope this wasn't too traumatic. This setup I'm using here is proper cowboy to film this, but there we go. So what needs to be done to speed up sprites? I have a few ideas. There's some obvious low-hanging fruit. My sprite code is flexible and compact, but not optimized. Currently, sprites are constructed from their 8x8 tiles every single frame. If I was to create all the sprites needed and store them in memory, this would consume too much memory even for a 2MB A1200. But maybe there's an intermediate approach, whereby I cache the most recently used frames. By doing so, blitting them becomes one operation, and we're not constructing the sprite like a jigsaw each frame. Furthermore, the caching part of this doesn't need to be performed in the vertical blank, so we could try to get it completed during the active display period. But aside from sprite complications, there are plenty of upsides. I'm pleased to report that the sprite export pipeline we're using works great. The reworked Sonic graphics from Rick using the new palette imported and worked first time. Where we've been struggling is with the tile layers. That's because I need to update Sonic LVL, the level editor, so that we can export 32 colour tiles for the Amiga, as opposed to the Mega Drive system, which exports 16 colour tiles that are assigned to 4 separate palettes, making 64 colours. So, to summarise, here's what we've got to do next. 1. We've got to adjust the level editor to output tiles in Amiga format. We've reached the limitations of what can be done with the vanilla Mega Drive tile format. 2. Optimise Mega Drive sprites. I think this will be the third rework of the sprite system, and it won't be the last. 3. Add more sprites and gameplay to Green Hill Zone. To emphasise, the blocker here is not porting the Sonic code. If I'd decided to target an 030 processor with loads of fast RAM, I could have had this up and running in a few weeks. The challenge is we're targeting an A1200 with much slower chip memory. Finally, I try to post a couple of updates to Patreon every month. Nearly all these posts are completely free, so please join if you're interested. But a special thanks to those who have subscribed. It's very generous of you and I really appreciate it. Come and say hello on Discord if you haven't already. See you in the next video.